Assalamualaikum warahmatullahi wabarakatuh. And hi. So today we're gonna present about our project, heat pump in lumber drying with refrigerant. I will introduce myself. So my name is Zulharis Putra bin Zulkifli and my matrix number is 210016.
My name is Muhammad Al-Fahim bin Jamaluddin and my metric number is 212974.
And my name is Muhammad Ibrahim bin Abdul Majid and my metric number is 212020.
My name is Nurin Izzati binti Sabri and my metric number is 211915.
Right, so let's move on to the introduction. So a heat pump is a device that uses a small amount of energy to move heat from one location to another. It is a type of air conditioner that can also be used for heating. Heat pumps are efficient and environmentally friendly alternative to traditional heating and cooling system. So this study aims to investigate heat pump efficiency in lumber drying using a closed cycle mechanical system. Heat pump efficiency measured by coefficient of performance or COP, ratio of heat output to energy input. Higher COP means more efficient energy to heat conversion, and COP varies between 2 to 4 depending on heat pump type, size, and temperature. Heat pumps are more efficient at heating than cooling. Efficiency decreases as temperature difference between source and sink increases. Right. So yeah, these are the application. And here we can see that here we have start from compressor, and then condenser, expansion valve, and then evaporator. So heat sinks and heat source. I think for the application part, I will pass to Ibrahim to explain more about this.
Okay, for the application we have three temperature. Four temperature is T1 is equal to negative 11.2, T2 is 99.231, T3 equal to 65.8, and T4 is equal to T1, which is negative 11.2. And the mass flow rate for this heat pump is 0.1214. That's right. I will explain about the formula. W equal to Q per COP. W is the work performance on the working fluid by the heat pump compressor. Q is the heat transfer from the lower temperature reservoir to the higher temperature reservoir. COP is the instantaneous coefficient of performance for the heat pump at the temperature prevailing in the reservoir at one instant. Measure the heat output of the heat pump by measuring the temperature of the air or fluid used to transfer the heat to the lumber and temperature of the lumber itself, as well as the flow rate of the air or fluid. Measure the energy input required to produce the heat by measuring the electrical power consumed by the heat pump using an electricity meter or similar device. Calculate the COP by dividing the heat pump by the energy input. Note that the COP of a heat pump used in lumber drying can vary depending on factors such as the type and size of the heat pump and the temperature of the air ground. Measure proper calibration of equipment and take measurement over a sufficient period of time for accurate reflection of the heat pump performance.
Okay, so thank you, Ibam, for the explanation for the application. For the modeling, similar to the vapor compression refrigerator cycle, heat pumps are machines that run on a similar principle. For example, there are heat pumps with an air supply, ground source, water source, or exhaust air. And in district heating systems, they are also utilized. And a refrigerant that is at room temperature gets compressed while the heating mode is on. This result, the refrigerant heats up, and to an indoor unit, this thermal energy can be transferred. And also a vapor compression refrigerating system is made up of the following components: in its most basic configuration, which is an evaporator, a compressor, a condenser, and also a throttling mechanism that is typically an expansion valve or capillary tube, which we call the connecting tubing. Next. And as we can see, this is another one. As we can see, this is a simple refrigeration cycle with vapor compression that consists of condenser, compressor, evaporator, and also the capillary tube that I have just explained just now. Next. And another one. So for this one, this is the thermodynamic cycle that we will obtain after we do the equation that EBAM has explained just now, and will be explained more in the discussion after this.
Okay, thank you, Nurin. And now I will explain more on our coding that we have made based on our theoretical value that we obtain, and through the value we are able to get the outcomes. Okay, so now I will explain on the coding that we have made. Okay, so for the input, we have made it so that you could put any temperature and it will detect whether it is compatible or not, compare with our theoretical value. So in order to get the percentage difference, we use the formula theoretical minus experimental over theoretical and times with 100, and we manage as an example, we tried the value -9 and 80, and as you can see, the value above from 2.39 until 14.87 is the percentage difference of the value above. The temperature above is all the temperature that is below 20% for the percentage difference, and could be considered quite accurate and can be used to obtain data. And for the value that is above 20%, it will continue to calculate until you get below 20%. Now, moving to our graphs. Through the value that we obtain, we calculate H using interpolator method, and we have managed to get H1 until H4 and S1 until S4, and we're finally able to plot this graph. And lastly, for discussion part, the coefficient of performance is a way to measure the efficiency of heat pump system, and it is the ratio heat energy system produces compared to the amount electrical energy it uses. A higher COP value means that the system is more efficient and can produce more heat for the same amount of electricity. So one of the advantage is that higher COP can save you money because it could provide more energy, and the system could use less electricity to produce the same amount of heat. And talking about the disadvantages, the high efficiency heat pumps could be expensive to purchase, and they may require specialized equipment or installations. Okay, that will be all from my part. I'll pass to the next presenter.
Right, so for the conclusion part, so as we can conclude here is COP is important to consider when evaluating the efficiency of a heat pump in the lumber drying process. high COP heat pumps produce more heat energy for a given amount of energy consumed and reducing energy costs and improving the overall efficiency of the lumber drying process. Efficiency of heat pump in the lumber drying process is important as it determines how much energy is needed to dry the lumber. And COP can be calculated by measuring or estimating the amount of heat energy produced and the amount of energy consumed by the heat pump. And COP can vary depending on factors such as heat source and sink temperature, size and design of the heat pump. Calculating COP can be useful for evaluating the efficiency of the heat pump and determining its cost effectiveness for the lumber drying process. I think that's all from us. Thank you.